This is Gianpaolo and I'll be doing part A of question 6. So part A states to write the first four non-zero terms in the general term of the Taylor series for f about x equals 1. So we're first going to calculate our derivatives, our first four derivatives of this series. So it's better if we put them in a table. And in the initial question, they gave us some information. Our zeroth derivative is going to be 1. And they gave us that our first derivative is going to be negative 1/2. And now we're going to calculate for our second and third derivatives. So by using the formula given to us in our initial question, which was negative 1 to the n times n minus 1 factorial over 2n, 2 to the nth, we're just going to substitute in n with whatever derivative we're trying to get. So for a second derivative, we substitute n with 2. And when we simplify it, we're going to get, we're going to get 1 factorial over 2 to the second. And that's going to be 1/4. And then we're doing the same thing for our third derivative. Substitute n with 3. And when we simplify it, we should get negative 1 times 2 factorial over 8. 2 factorial is 2 times negative 1, negative 2, so we're going to end up getting negative 1/4 for our third derivative. So now that we have our derivatives, we can write out our series. We're going to follow this format. We're going to get our zeroth derivative, which is 1. I'm going to multiply that by x minus 1 to the nth term, which is 0, over n factorial, which is 0 factorial. We're going to repeat this for our next three terms. So for our first derivative, it's going to be negative 1/2 times x minus 1 to the 1th, 1 factorial plus 1/4 times x minus 1 to the second over 2 factorial plus negative 1/4 times x minus 1 to the third over 3 factorial. And then we want to get our general term, so we're going to write down plus dot 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 plus and then write down our general term right here. And it's going to follow the same format. We're going to use the formula given to us in our initial question. We're going to use that as the derivative, so it's going to be negative 1 to the n times n minus 1 factorial over 2 to the n times x minus 1 to the n over n factorial, and then plus dot dot dot. And then we're going to simplify the series. So this first term is going to end up simplifying to 1 minus 1/2 times x minus 1. Since 1 factorial is just 1, we can remove that from the denominator, and x minus 1 to the 1 doesn't do anything. So, and then our next term plus okay, so it's going to be 1/8 times x minus 1 to the second. Then our next term minus 1 over 24 times x minus 1 to the third we're only multiplying -1/4 times our factorials, and that's how we're getting -1/24. And then we simplify our general term, and that's going to be -1 to the n times x minus 1 to the n over 2n times n plus ... And this is going to be our final answer. This is Gianpaolo, and I'll be doing question 6, part B. So part B states the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence and show that the work leads to your answer. So as given in our question, they gave us that x equals 1, so the Taylor series is going to go about that, so that's going to be our center. So our center is going to be x equals 1. And then it says a radius of convergence of 2, so our radius is going to be 2. And from that, we can get our endpoints by subtracting our radius from our center, and then adding our radius to our center. And we end up getting -1 is less than x, and x is less than 3. And those are going to be the endpoints that we're going to be testing. And we're going to test these endpoints in a summation, which is going to be 1 plus the sum of 1 to infinity. And we're going to go back to part A, and we're going to get our general term that we simplified, and we're going to input it into the summation. And that was -1 to the n times x minus 1 to the n over n times 2 to the n. Okay. So now we're going to use this formula to test our endpoints, and we're going to substitute in these endpoints with x. So f of -1 equals 1 plus the summation of 1 to infinity times -1 to the n, and we're substituting in -1, so it's going to be times -2 to the n over n times 2 to the n. Just going to keep on simplifying, and we can simplify even more if we split -2 to the n into -1 to the n times 2 to the n. And we're doing this so we can simplify this equation further, because as you can see, the 2 to the n's cancel out here, and we end up getting 1 plus summation of from 1 to infinity of 1 over n. And from this we can tell that this is this endpoint is going to diverge, because this is a part of the harmonic series. Okay, so now for our next endpoint that we're going to test, 3, I'm going to substitute in 3 with x, so just rewrite this. -1 to the n times, and then we're substituting in 3. So that's going to be 3 minus 1, which is 2 to the n, over n times 2 to the n. And then this is going to be simplified. As you can see, there's 2 to the n on the numerator and the denominator, so we're going to cancel that out. And we end up getting 1 plus the summation from 1 to infinity of -1 to the n over n. And this is going to converge. And we know this because this series is part of the alternate harmonic series. And so based off of this information, we can get our interval of convergence, which is going to be from -1 is less than x, and x is going to be less than or equal to 3. So -1 is not going to be included since it's diverging, but 3 is going to be included because it is converging. And this is going to be our final answer.
So question 6C of the 2016 AP Calculus BC free response questions asks, the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first three non-zero terms of the alternating series to approximate f of 1.2. So in question 6A, we were tasked to find the first four non-zero terms, and here we just need the first three, so we can just use the first three of the four that we found. And the first three is just 1 minus 1/2 times x minus 1 plus 1 over 2 squared times 2 of x minus 1 squared. So that's the first three non-zero terms, and we're told to approximate what f of 1.2 is. So you just plug in 1.2 into x, so 1 minus 1/2 times 1.2 minus 1 plus 1 over 2 squared times 2 times 1.2 minus 1 squared. And we're allowed to use a calculator for this question, so I'm gonna just use a calculator. You probably don't have to, but yeah. So just plug in 1 minus 1/2 times 1.2 minus 1 plus 1 over 8, because 2 squared times 2 is 8. So 1 over 8 times 1.2 minus 1 squared, and that gives us 0.905, and that's the answer. That's what f of 1.2 approximately equals. So the answer is just f of 1.2 approximately equals 0.905, and that's the answer to 6C.
Okay, so for this question, it's asking us to show the approximation found in part C is within 0.001 of the exact value of f of 1.2. So if we find the first few terms of the series that we found in part A, if we just find them really quick, it would be f of x. If we get them at at x equals 1.2, it would just be 1 minus, that would be 0.2 over 2, which is 0.1, plus, that would be 0.004 over 8, which is 0.005, and then plus all the remaining terms. We're just only finding the first few. So if we want to rewrite that neater, these first few terms, see, these are the first few terms. So, so based on finding just these first few terms, gotta add the little ellipses, we can tell that this series it alternates, because we can see that each term switches from positive to negative, positive, and then it'll keep switching as you go further into the series. And that also, as you go further into the series, we can see that the size of each term, whether it's negative or positive, we can see that it's getting smaller and smaller. It's decreasing, like from 1 to 0.1 to 5 thousandths. So to find the exact value of f of 1.2, we would have to use the approximation from part C, we got from part C, which is that second degree of the Taylor series we found at x equals 1.2. And we would add that to the remainder of the series at x equals 1.2, and the remainder of that, so this is the second degree of the Taylor series. Oh, or just, it would just be x. And then this is the remainder, this 1, 2, 3, 4th term, plus all the terms after that. So that would be just the remainder. So we would add this to the remainder at x equals 1.2. So So this remainder includes this fourth term. And let's see, so for this question, all we need to do is make sure that if you subtract that approximation from part C from f of 1.2 minus t, that it would, or we just have to make sure that this difference is less than or equal to 0.001. That's what the question is asking. So, if we can find that the value of that first term after this one, that first term after the second degree Taylor series, so this fourth term, if we can find that this is less than 0.001, then we know that that's the greatest amount the approximation can be off by, because as you go further and further into the series, you're going to be adding and subtracting smaller and smaller values, because it's decreasing with each term, or the value of each term decreases as you go further and further. And then it means that the full remainder isn't going to go above the absolute value of that fourth term after the second degree Taylor series. So, so if this is the greatest value, where we write that here, -1 over 2 cubed times 3 times the quantity of x minus 1 cubed. So if we can find that, if this is the greatest value that the approximation of f of 1.2 can be off by, all we have to do is plug in 1.2 for x on this fourth term and make sure that it's less than or equal to 0.001. And we can use absolute value on this because it doesn't matter whether it's positive or negative. We just have to make sure that the amount of how much we would just have to see the amount of how much the approximation's off by. So if we plug this into the calculator, which I left on the bed. Okay, if we plug this into the calculator, oops. Or I guess if we simplify this, we could just say, because we have to plug in 1.2 for x. So if we simplify this, since we don't have to include this negative because it's absolute value, so it would just be 0.2 cubed over 2 cubed times 3. So if we just plug that into the calculator, divided by 2. So it's giving us 3.333, and it's repeating, and it's giving it to us in scientific notation. So if we just 1, 2, 3, 4, if we move that decimal by 4, this value is 0.0003 repeating, and that's clearly less than 0.001. So that's how we would check it. And I guess if we should probably write out everything that we did. So we're finding that the difference between the exact value of f of 1.2 minus the second degree of that Taylor series is going to be less than that fourth term, which is -1 over 2 cubed times 3 times the quantity of x minus 1 cubed, or it would be 1.2 for x, because that's where we're evaluating it, which is equal to 0.0003 repeating, which is less than 0.001. Oops. So that's how we show that the approximation is within 1,000th of the exact value of f of 1.2.